Okay, for this tutorial, this is for electronics. I'm going to show you how to simulate the Arduino using Tinkercad. For your Arduino tutorials, you're going to be using the SIK or the SIK guide. In Google, if you type in SparkFun SIK guide, you should get to a website like this. Or you can type in SIK experiment code for Arduino v3.3. Go and press this download button and you should be left with a PDF that looks like this. We're going to be following this PDF guide for our Arduino tutorials. When we go back to doing practical stuff, it's going to have some logistics in there that you have to install the drivers on your computer, and you have to connect it by a cable, by a USB cable, which for our simulation we do not have to do that. So for our guide on Tinkercad, we're going to start straight from if we scroll down to the start of experiment number 1, which is this one, number 1, it's on page 21, and it is a blinking LED light. The schematic of the circuit is simple. We're just going to plug the LED light in pin 13, LED light, and we need a resistor, and it's going to go to ground. So how we do this in Tinkercad. We're going to log into Tinkercad, so you have this and you make sure you're logged in. We're going to click circuits, and we're going to create a new circuit. So then we have a circuit. We have over here a bunch of components. The first thing we're going to get is an Arduino, and we're going to put that in, and we can call this the SIK. I believe we can call it, right? Awesome. So we can call it, and notice how this is a red Arduino and this is a blue Arduino. These are different because this one is red and this one is blue, but functionally they're actually the same. This one over here has the pin-based Arduino chip, but you can also get ones that have the surface mount Arduino chip. It depends on your supplier, but all Arduinos conform to a same manufacturer specifications where they have this rectangle and like this angled parts out here. The pin layout is always the same. See how they're kind of offset? Those are standard, so anything that plugs into one Arduino can plug into other Arduinos. The next thing we're going to need to simulate this, see how this is an Arduino with a breadboard next to it. So we are also going to make a breadboard. So over here, we'll just get a small breadboard. We can drag it in. We don't need to give this breadboard a name. And then, if we scroll down, we can see how we are going to set up this circuit. We need to get a wire to connect from pin number 13 to pin number 2E. So let's find some wire. Do we have wire? Or I think we just oops. Let's put before we put the wire, let's just put in the components. Alright, so we want to get an LED. As we put an LED, we have the anode and the cathode, and so the cathode is the negative part and the anode is the positive part. So if we're going to, can I rotate this? Okay, so we can rotate this part by clicking this LED light, and if we press the R button, or if we press up here in the top right, top left hand part of the screen, we can rotate this part. I just want to rotate it like this, so it's going to be the same orientation as our LED over here. See how we have the flat part is going to be on base in row number 3, and our positive part is going to be on row number 2. So now I can click and drag this, and I think we can just click it like this, and I assume it's connected to both of these. Okay, so and now we need to get a resistor. How big is this resistor? This is a 330 ohm resistor. So let's click resistor, and this resistor we want to connect this resistor between this point Is it going to fit nicely? It is not going to fit nicely. We can just put it in straight, I think. Okay, and how big is this resistor? Its resistance is 330 ohms. And then we need to start connecting some stuff up. So we can just click and drag stuff to the circuit. We need to connect this anode to pin number 13. So let's just go, we can go out here, then we can go out here. So I'm just clicking and dragging and making points. Okay, ooh, we can make it nice and neat. The other ones, we need our positive and negatives. We can change our colors. So let's say black is going to be connected to our negative, and our negative will connect to our ground pin. There are two ground pins. It doesn't matter which one you select, because they both have a ground written on them. But then we want to connect to the 5 volts, and again for, no. This one over here, we want this to be, and this one we want it to be red. Okay, so now, in theory, we have this circuit plugged up. We don't have any code to run, so what we're going to do is we're going to press our code button, and then if we go down to our first sketch over here, we're starting to see some code. So over here we have, we can do Arduino code by blocks, which is similar to like a Lego. You may have seen that one, or we can just do text, which is, yep, continue. We want the standard text code. So when you do a Arduino code, there are some features that are common in all the codes. As you look over here in circuit number 1, these are given to you by an example in the SIK guide. Also, if you I'll show you at another point how you can find these SIK codes, but the blinking LED light circuit is a very common one. So when you have an Arduino code is set up in 2 major areas. We have this part over here, which is called the void setup, and then we have over here, which is called the void loop. The void setup, this is where we put all our conditions, that when we run the code is going to start from line 1, then go line 2, 3, 4, and so forth, so forth. We want it at the start to go through all our starting conditions. So this is where we're defining pins. We might want to start constants, and all those things we want to talk about it at the start before it does the code. And then the void loop is the program that we want it to keep going over that program forever. So what we need to do with Arduino is, these are all pins. We need to tell the Arduino what pin is doing what, especially the numbered pins. These ones over here, like the power, we don't have to tell them that 5 volts or ground, but A0 to A5 and pin 1 to D13, these all have to be told what they're doing. So pin mode 13, right? That means this is pin number 13 over here. This is an output pin. So we're telling the Arduino program, you're supposed to be outputting a message from this pin over here. Later when we deal with sensors, we're going to have some of these pins are going to be set to input pins. Alright, but for now we're just doing output. So then we go to our void loop. Digital write, so all these pins over here, see over here it says digital pins. These are digital pins, these are the analog pins. We won't worry about those for this tutorial. But analog pins can have a range of values. They're good for, like, if you have a temperature sensor or a resistor, like a potentiometer, and you want to get multiple values out. But for now, we just want a digital pin which is on or off. So digital pin, we're going to say digital write, which is going to tell the Arduino, this is the signal you're going to be outputting on D13. So it's saying digital write 13 is high. So it's going to send the input to have a high on pin 13, and then we're going to say delay 1000. When you have delay and you have the number in here, that is by default how long in milliseconds it is going to wait. So this is going to be a 1 second wait. Then we will go to digital write 13 low. So now we're saying to the Arduino, for that pin 13, now write it as a low, so low voltage. Then we will go to delay 1000, and then the loop is finished. Once the loop is finished, it's going to start all over again. So it's going to go high, wait 1 second, low, wait 1 second, high, wait 1 second, low, wait 1 second, high, wait 1 second, low, wait 1 second. So if we start this simulation, are we working? We have it on. Hold up. Oh, sorry, my bad. I pressed somewhere in the code. So if you press start simulation, the simulation should be going, and here we see the light is going on for 1 second, off for 1 second, on for 1 second, off for 1 second. Similar to like the FALSAD simulator, the simulator time is not the real world time because it could take your computer like more than a second to calculate 1 second of Arduino time, but we see here the light is flashing. If you have your mouse in a particular part of the code, so stop simulation, you can actually press a particular line. Let's say line 12, and if you press start simulation, the code will go all the way up till you hit that line. So you can, it's really good for debugging a particular Arduino code. So right here it's stopping on the low. Then we can stop our simulation. We can change some of these values. So let's say we want it to be let's say we want it to we want to add some more blinking lights. Let's say we want, so I've done this code twice, and let's say now we want it to be so now what has this code done? This code is going to have a flashing light for 1 second, and then it's going to do 2 really fast flashing lights. So if I press simulate, we should have on, so we have our 1 flash and then 2 flashes. I'm actually going to change this last one to 1000 because it will make it look better, I think. On, flash, flash, 1, flash, flash. So that's our simulation through the simulator. If you were doing this through the SIK guide and in the real Arduino, you would get your code over here, which is what we have over here. Then you have to verify it and upload it. So the differences we have here is in this Arduino tutorial, we have over here the Arduino cable. Right, this will be plugged up to your computer, and then you're going to have to upload this code to your Arduino, and where you're writing this code in the Arduino editor will have these buttons. It will have the verify and upload button. If we look over here, this is an example of what the box looks like in the Arduino application. You press the tick button to verify. This makes sure that it goes through your code to make sure there's no programming errors. It's not going to stop your code from working incorrectly, but it ensures that your code will work. So it's going to look for things like, if you have a particular, if we delete a semicolon over here, which is necessary for the code, and if we press share, simulate, it's going to say there's an error. It's going to say over here there's a problem. This line isn't working because the correct code is you have to put a, I think it's a semicolon at the end of the digital write. Wait, was that the correct one? Oh, it's this one over here. Okay, we're missing a code over there. Now it should be working. Yep. So when we do verify on the Arduino, you'll see what's wrong with your code. You can verify your code using the Arduino program and then copy paste it into the simulation, and it should work. but then you upload. So we obviously don't have to upload. Other things, we don't have to worry about blowing up our circuit. So if we took out this resistor, if we change this resistor value to 0, the light is going to be really bright. We are going to get an exclamation mark next to the light, which I think is the circuit trying to tell us that it's overloaded. That's actually too bright. But in our simulation, we're not going to break our light. So that's one nice feature of that. We're not drawing, we can draw infinite power from the Arduino, and we don't have to worry about force feedback. So like changing light powers could affect some very sensitive Arduino equipment. Right, that's for guide number 1. I want you to try guide number 1 and then go on to guide number 2, where you're adding components that still exist inside the Arduinoverse code. So for the next guide, over here, we have the same thing with LED lights. We have a potentiometer, which, yeah, I think it's just this one over here, right? Yeah. You have a potentiometer, which you see here, 3 pins over here, and you can have wires, and you can do that. Errors that you're going to find, the LED lights, remember the directions. LED lights are polarized. So you have to have them connected in the right way, or they won't light up. But resistors do not need to be connected up in the right way. Alright, that should be it for this tutorial. Good luck.